Okay, gentlemen, our last lesson for the semester is going to cover the unit circle. So most of you have done this before. If not, that's okay. I'm going to show you how to construct it. And yes, on your assessment, you will have to construct a unit circle. So let's start with the basics. The unit circle is just a circle with a radius of 1 unit. So if I draw in a radius here, the value of that radius is 1. And I want you to think about this point that it hits the circle at, and that's some point x comma y. Now, from the origin, I can make a triangle at that point by going over x units and up y units. And we're going to think of the acute angle between the x-axis and our radius. We're going to call that our angle theta, okay? And so by definition, I could say that cosine of theta is going to be adjacent over hypotenuse. The adjacent side is x. The hypotenuse is 1. X over 1 is just x. Likewise, I could say that sine of theta is opposite over hypotenuse. The opposite side of theta is y. Hypotenuse is 1, and y over 1 is just y. So what we've kind of stumbled upon here is that note that that point xy is some point on the unit circle. Well, what we've just shown is that since cosine is equal to x and sine is equal to y, then for any angle that intersects the unit circle, if I know the point that it's intersecting at, then the x-coordinate at that point is going to be cosine of the angle made between the radius and the positive x-axis, so this angle, and the y-coordinate is going to be sine of that angle, okay? So that's really helpful if we know certain values on the unit circle, because we can construct trig values out of those and solve different types of problems with those trig values, all right? So in that case, to remind us of our two special triangles, we're going to have our 30, 60, 90 and our 45, 45, 90. I'm actually going to label them on the next slide for us. So the first thing I'm going to do is sketch out a 30, 60, 90 and a 45, 45, 90. All right, this one can be my 30, 60, 90, so I'll label the small angle as 30 degrees. Here's my right angle. My big angle is 60 degrees. And 30, 60, 90 goes 1, 2, rad 3. And over here I'm going to put my 45, 45, 90. This one is isosceles. It's just going to help me build my my unit circle. Okay, so we'll say this is 45 degrees, and this is 45 degrees, and this is 90, and 45, 45, 90 goes 1, 1, rad 2. We're going to use those to help us construct our unit circle. So the first thing I'm going to do is I'm going to go around and label all my values of my angles, my special angles, in degrees and in radians. So we'll start with degrees. So start with the quadrants. I got 0 degrees, I got 90 degrees, got 180, 270, and then if I come back around, this is again 360, okay? We'll go ahead and label these in radians as well. So remember, when we're going from degrees to radians, we're going to multiply by pi divided by 180, and I'll show you a quick way to do this if you have a calculator. But we're going to keep these exact in terms of pi. So 0 degrees in radians is still 0 radians. And then 360 is 2 pi. These we should already have memorized. 90 is pi over 2. 180 is pi. 270 is 3 pi over 2. Okay. So our other special angles. they're either going to be a multiple of 30 or 60 or 45. So my first one is 30 degrees, then 45 degrees, then 60 degrees. Okay, over in quadrant 2, if I go ahead and add 30 degrees to 90, I get 120. If I add 45 to 90, I get 135, right? And if I add 60 to 90, I get 150. Okay, quadrant 3, if we add 30 to 180, we get 210. If we add 45 to 180, we get 225. If we add 60 to 180, we get 240. And then quadrant 4, if we add 30 to 270, we get 300. If we add 60 to 270, 45 to 270, we get 315. And then if we add 60 to 270, we get 330. Oh, and I just noticed they actually gave us spots to put the 360 and the 2 pi. So put those in the correct location here. So this is 360 and 2 pi. Okay, so using our pi over 180, all of our radian measures are gonna have pi in them. We know that. If we wanna do it quickly in a calculator and in Desmos, just do your degree measure divided by 180 and then hit the fraction button. So in Desmos, I can do 30 divided by 180. It'll give me a decimal to start with, but if I hit that little fraction box in the upper left there, it'll change it to me. So that's 1/6. So I end up with pi over 6. So this is pi over 6. Same idea here, this will be pi over 4, and this is pi over 3. Likewise, 120, I'll show you one more time. So if I do 120 over 180, and then hit the fraction button, so that's 2/3, so 120 is gonna be 2 pi over 3. Likewise, I can do that for 135. I'm gonna get 3 pi over 4. And then this is gonna be 5 pi over 6. Okay? 210 is 7 pi over 6. 225 is 5 pi over 4. And 240 is 4 pi over 3. And finally, we got 300 is 5 pi over 3. 315 is 7 pi over 4. And then 330 is 11 pi over 6. Okay. So now we have all of our angles, both in degrees and radians, and I just want to fill in the coordinates of my sine and cosine values for each of these. So one thing I want to notice is that each one of these, we can build a triangle out. So let's start with pi over 6, which is 30 degrees. So I could build out this triangle with the x-axis, and this would be a 30-degree angle, basically, right? And so what I have is a 30, 60, 90 triangle that I'm looking at from the perspective of a 30-degree angle. Okay, so I'm gonna go back up to my 30, 60, 90 triangle. I'm gonna use that to find sine and cosine of 30 degrees. So here I'm in the perspective of 30. So cosine of 30 is adjacent over hypotenuse. So it's just gonna be root 3 over 2. Remember, cosine is my x coordinate. So root 3 over 2. Sine of 30 is opposite over hypotenuse, so that's just going to be 1 over 2. All right, so 1 over 2. Cool. Now we're on to our 45-degree angle. So same idea, I could build a triangle out of this. This would be a 45, 45, 90 triangle. I already have that drawn, so I'll just use the one I drew in the upper right-hand corner here, and we're looking at it from the perspective of the 45-degree angle. All right. And so I would say sine is opposite over hypotenuse, 1 over rad 2. If we rationalize that, we end up with root 2 over 2. Cosine is adjacent over hypotenuse, also 1 over root 2. So again, if we rationalize that, that's root 2 over 2. Okay? And finally, we look at our 60-degree angle. So now we're going to be in our triangle, our 30, 60, 90 triangle, but now I want you to look at it from the perspective of the 60-degree angle. So cosine of the 60-degree angle is going to be adjacent over hypotenuse, or 1 over 2. And sine of the 60-degree angle is going to be opposite over hypotenuse, so root 3 over 2. All right, awesome. So now, we've built our 3 special angles. We find sine and cosine of all 3 of them. And we have a bunch more to go. So we have 3, 6, 9 more special angles to go there. However, we don't actually have to reconstruct it. We can just use the idea of reflections. What I mean by that is this. This point here on the unit circle, if I reflect it across the y-axis, becomes this point at 5 pi over 6, which means the only thing that's going to change is the sign of our x-coordinate. Our y-coordinate is going to stay the same. So I can use that idea. All of these in the first quadrant are going to be reflected into the second quadrant, and the quantities are going to stay the same, but the x values are going to have the opposite sign. So instead of positive root 3 over 2, this is going to be negative root 3 over 2, positive 1/2. This is going to be negative root 2 over 2, positive root 2 over 2. And this is going to be negative 1/2, positive root 3 over 2. Okay? Boom. We quickly were able to fill in quadrant 2 of our unit circle. To do quadrant 3, note that this point at 5 pi over 6, I can reflect it over the x-axis, and I'd be at this point at 7 pi over 6. So the coordinates, the quantities remain the same, but now the y value is going to change. The x value, we're still on the negative side of the x-axis, so it's going to remain negative, but now the y value is also going to be negative. Right? So let's fill those in. This now becomes negative root 3 over 2, negative 1/2. This is negative root 2 over 2, negative root 2 over 2. And the last one is negative 1/2, negative root 3 over 2. All right, and once again, we can think of this as a reflection. So this point at 4 pi over 3, if I reflect it over the y-axis, will become this point at 5 pi over 3. So now we're at the positive side of the x-axis, but the negative side of the y-axis. So our x values are positive, our y values are negative, but they're just reflections across the y-axis. So this will be positive 1/2, negative root 3 over 2, positive root 2 over 2, negative root 2 over 2, and finally, positive root 3 over 2, negative 1/2. Okay, we've got our special angles. The values for sine and cosine are all filled in here. And now I just want to fill in my quadrants. And since this is a unit circle, all of these values are either going to be 0, 1, or negative 1. So here the x value is 1, since we're to the right 1, and we're up 0. Here, my x value is 0, but my y value is 1. Here we're at negative 1, 0. And finally, down here at 3 pi over 2, we're at 0, negative 1. And there we go. It's a quick way we can construct the unit circle, as long as you've memorized your special triangles. So now let's talk about how we can use the unit circle to answer some of these questions. We're just going to do a couple examples. All right. Example 1, evaluate the 6 trig functions at each real number. I'm not going to do all of these. I'll do a couple of them. Let's do, Actually, let's do B, C, and D. I'm going to skip A. All right. So I want sine of 5 pi over 4, cosine of 5 pi over 4, tangent of 5 pi over 4. So, to use my unit circle to figure this out, let's go back to the unit circle. Let's identify the angle at 5 pi over 4. We're down here. Okay? Let's note that cosine is my x coordinate and sine is my y coordinate. They're both negative root 2 over 2. So I have sine of 5 pi over 4 is negative root 2 over 2. Cosine is also negative root 2 over 2. Tangent is sine divided by cosine, remember? But since sine and cosine are the same, when we divide them, we're going to get positive 1. Okay? If we then look at cosecant of 5 pi over 4, secant 5 pi over 4, and cotangent of 5 pi over 4, those are just going to be the reciprocals of each one of these. The reciprocal of negative root 2 over 2 is negative 2 over root 2. And if you rationalize that, you can try it, multiply by root 2 over root 2. It actually simplifies just down to negative root 2. So both cosecant and secant will be negative root 2, and then cotangent, the reciprocal of 1, is still 1. Okay? You know what? I'm going to skip D as well. Let's do a quadrantal angle, so we'll do sine of pi, cosine of pi, tangent of pi, and then we'll have cosecant pi, secant pi, cotangent pi. All right. So again, we're just going to our unit circle. We're going to identify where is pi. It's over here. We call it a quadrantal angle because it falls on a quadrant. So it's just the left side of my unit circle. Cosine is negative 1 there, and sine is 0. So we're going to say cosine is negative 1. Sine is 0, and tangent is sine over cosine. 0 divided by negative 1 is 0. Okay, now our reciprocal functions. Well, the reciprocal of 0 is undefined because we'd be dividing by 0. The reciprocal of negative 1 is still negative 1, and again, the reciprocal of 0 is undefined. That's it. That's basics on how to use the unit circle to evaluate the 6 trig functions. Important to remember that tangent is just sine over cosine. Okay, last example. I'm given a point on the unit circle. I want to evaluate the 6 trig functions given this one point. So the only thing we got to remember for this one is that my x coordinate is cosine of theta and my y coordinate is sine of theta. So right off the bat, I already know that sine of theta is 15 over 17, and cosine of theta is negative 8 over 17. And then again, tangent of theta is just sine divided by cosine. So if I do 15 over 17 and I divide by negative 8 over 17, that's really multiplying by the reciprocal, so 17's cancel. I'm left with tangent is negative 15 over 8. Okay. Reciprocal functions, you just got to remember what goes with what. The reciprocal function for sine is cosecant, so that's going to be 17 over 15. The reciprocal function for cosine is secant, so that's going to be negative 17 over 8. And the reciprocal function for tangent is cotangent, so that's going to be negative 8 over 15. Okay, so it's pretty short and sweet. Hopefully you got some understanding on how to construct the unit circle and how to use it. I'm going to go ahead and have you work on your group work and your composition books. And there will be a Delta Math problem set. All right, thank you.